Okay, people, so polymorphism and virtual functions. Let's review what we have learned yesterday. We said that if I write a if I like to write a shape hierarchy like this, a shape class, and my plan is to derive many other classes out of this class, and I am thinking about this class here. I mean, as a data member, I can't put in there much because I don't know the parameters of a shape. I don't know if it's a circle or rectangle, polygon, or some other shape that I didn't think of. So what am I gonna do? Well, I mean, you might say that if you don't know how to write the class, if you don't know all the specific, then don't write it. No, we don't do it that way. There are still some things possible with this shape class. For example, I know that any shape that can derive from this class should have an area and a perimeter function defined. Even though I don't know how to write it for this class, I know that it has to be there, right? That's why I said that I am going to write a class like this, a shape class. It will not have any data members. It will not have any data members, and I will define this area and perimeter functions. They will just return the area and the perimeter of the shape. But for now, I am returning minus 1.0 because I don't know how to implement it, and I have to implement something. But I know how to implement is larger. How am I going to implement it? I am going to implement it by calling the area functions of this object and the other object, and by comparing them. So it's going to be like this. I will get a shape reference, other shape reference. I am calling my area, and I am calling others area. I compare them, I return results. So even though I don't know the specifics of the class, I am writing this is larger class directly. Okay, I am writing this is larger class directly, and I know that it's going to work for all kinds of shapes. Why? Because remember this one, circle C1, rectangle R1. I can call C1 that is larger R1. R1 is a rectangle, is larger is expecting a shape, but it works, it is okay. Why? Because there is an is a relationship, right? Is a relationship, it works. So somebody yesterday asked, why don't we just get rid of is larger here, right? And write is larger for all the classes that we are deriving from the base class, right? I mean, don't write is larger in this one, but write it here, there, and there. And that way I don't have to think about polymorphism and etc. and that kind of stuff. But that is a problem. What is the problem? Problem is this. I cannot compare in that case a circle with a rectangle, right? How are you going to write the is larger? How are you going to write the is larger for circle then? I mean, circle has to take okay, can we write it? Can we write it somewhere? Where is my, this is circle CPP. If I like to write the is larger, let's say I did not write is larger here, okay? I did not write is larger here. If I like to write is larger for this circle class, let's try to write it and let's try to implement it. I need some space for, okay, I know how to do it. I can do this. Not that, but that. Move it down a little bit. Okay. So for circle, I am writing is larger. And I assume that there is no is larger in the base class. Boolean circle is larger. So what kind of parameter does it going to take?
Shape.
What?
Shapes.
Okay, good. Let's take shape. Constant shape reference other and return. Why don't I copy the same thing, right? Let me copy this part. Okay, so I did it this way. Does it compile? Does it compile? The base class doesn't have a is larger function. Okay. Does it compile?
I think not, because
What?
I don't know if the circle.cpp has the information from the shapes.h, because does the circle know the other stuff about the other shapes? No. I'm trying to say that.
Well, they are virtual. They are both virtual.
Yeah, okay.
They are both virtual. So that means what? When you say O dot area, it has to wait until runtime to see what kind of object is that O. Is there a circle? Is there a rectangle? Is something, right? Okay. Does that compile? Yes, it should compile, right? I mean, the area is a function of shape. Area is there. Area is my function too. Yeah, okay. It is there too. So it should work, right? So this idea seems to be working. Let's not write this is larger in here, but repeat this is larger in all the other classes. We kind of addressed that problem that somebody has asked, but the problem here is what? The problem here is there is some other problem in terms of designing of this software. Every time I make a new class, I have to repeat this code, right? What if I don't repeat it? If I don't repeat it, if I forget, compiler will not tell me anything, right? Compiler will say nothing. Compiler will be happy because you don't have to implement this is larger anywhere, right? It's just a regular function that you don't have to implement. So some of the classes might have missing is larger functions, right? So it is definitely better to implement this function in the base class because it is common to all the classes and you want is larger to be valid, is larger to be a function of all the classes that you have. So what you're going to do is, no, don't do this, don't repeat this here, okay, for all the classes. Keep is larger in your base class, okay. But the thing is this, if you don't make these functions virtual and virtual, okay, both of them, since this is largely part of the shape class, it will be compiled with the shape.h and shape.cpp. Remember, to be able to compile shape.cpp and shape.h, okay, you need just two files, shape.h and shape.cpp. That's it. This one and this one will call the base classes. These two will call the base classes area functions, which will return minus 1.0. Okay, doesn't matter what kind of shape you are sending. It will work. It will compile, but it will definitely call the base classes area and perimeter functions because they are not virtual. Since I made them virtual, now I know that. Definitely, the compiler will delay the decision. Okay, to decide, will delay the decision for the selection of the area functions until the runtime. During the runtime, it will take whatever is passed, and it will check the object. Well, it's a shape, yeah, I know, but what kind of shape? It's a circle? It's a rectangle? It is something else? Okay. If it is, then I'm going to call that one. Yes.
It should be possible in the second compilation when we link both.
What is second compilation?
First, we compile our library files like shape CPP, and
Yeah.
then we link them
Yeah.
by compiling main
Uh-huh.
CPP and.
That's not called second compile. That's called linking.
Whatever. In linking.
Well, okay, good.
In linking process, we can detect what is the type of.
No. During linking, okay, during compilation, you may not know what kind of shape you are getting. Only it is the runtime. During the runtime, you are going to know it.
But we know what is the type of the.
No, you cannot, because
main CPP.
there is only one larger. Okay, there is only one is larger function. Okay, and you may call it with many different types of shapes. Okay, and this is larger function cannot know what kind of shape it is getting. Is larger doesn't know it. You are saying that I am going to modify the code for is larger, okay, during linking and something like that. No, it doesn't work. Suppose I have a vector of shape pointers, okay, vector of shape pointers, and I am comparing myself against these objects pointed by the pointers, right? I don't know what kind of shape I am going to get, even during the linking.
But in linking, we know what are the.
No, you cannot know. Okay. You asked this question yesterday. You keep asking me question, but you are not doing anything yourself. Okay. Let's do this. He's asking good questions. I don't like him much, but okay. A shape, okay. Choose max. Choose max is going to return the maximum area shape out of this one. Okay. So let me do this. A constant vector of shape pointers. Okay. A constant vector of shape pointers. Its name is V. Okay. So the task of this function is to return the maximum area shape. Since I have the shape pointers, I am going to return a shape pointer here. And I assume that there is at least one element in it. So let me do this. Shape pointer max is V0. Okay? So I am going to do this. For auto shape pointer V, if, you tell me, if
Shape pointer, the reference shape.
SP, well, okay, not that, but I'm going to use, okay, SP arrow area is greater than max dot area, okay,
Max.
then max is that one, right? Max is SP. And at the end, return SP. Okay. So this one, I can write this with the shape class as a global function without knowing anything about the circles, rectangles, polygons, etc., right? The solution that you are saying that during the linking, I know what kind of object it is getting is invalid, right? Because this vector can change during the runtime. I can push back elements to it. I can remove some of them, right? And my customer is going to dynamically change this vector too. You cannot know, because during the runtime, you cannot know what kind of vectors there will be, okay? Even the designer of the software, I forgot this.
Finite state machine, we can know.
What?
It's finite state machine, then we must know. We can know. Because everything is finite.
Okay, you are taking it too far. No, no. Well, of course, computers are deterministic machines. I know what they are going to do. But the thing is that to be able to know what they are going to do, you need to run the program first. Okay? Yeah.
Otherwise, compilers shouldn't exist. All languages should be runtime.
No, no, you don't know what you are talking about, okay? I am not going to take time. We can talk together after the class. You don't know what you are talking about, okay? But that was a good question. Did you understand the answer? No, huh? No? Okay. But other people understood it, okay? There is no way other than running the program and telling, even if you run the program and say what kind of shape is going to take, then you need to keep that information somewhere, and that information will be much larger than your program itself. Okay. Okay, let's go back and let's talk about this. And we said that that's why we keep this enlarged in this one. And this is again, although I didn't like the question, but this turned out to be a good function. Polymorphic calls, area and area, right? Oh, this is max area. I hope you are noticing these kind of errors and you are telling me. You are not telling me. How many people noticed that I did it wrong? That was wrong, right? Max is a shape pointer. It cannot be a dot. It has to be a arrow. Nobody noticed it? Okay, that's a bad sign. So this function, again, does not depend on circle class, rectangle class, or anything like that. To be able to compile this code, you only need to include shape.h, that's it, right? Very generic code. Remember what we are doing in this course of object-oriented programming? We are trying to write generic code so that it is reusable. It doesn't depend on anything, okay? It is not specific to anything, so it can be used. It can be used for many new classes. So this choose max could be used for any shape classes that I can derive from the shape class. As long as it is derived from, okay, as long as it is derived from shape class, this one will work. As long as this, okay, this area function is a virtual function. You are telling the compiler that it's a virtual function. Okay, yes.
If I have a shape vector, can I put one circle, one rectangle?
Yeah, sure. Yeah, that's what I did, right? This is shape pointer vector, and you can, since circle pointer is a shape pointer, okay, I can, okay, let me, in my main function, I could, did I have a main function in there? Yeah, well, yeah, okay. Let me modify this place and let me do it that way. In my main function, let's make a vector of shape pointers v, and I am going to initialize it with c1, address of r1, and address of s1, and I am going to call that function, call choose, what was the return max, choose max, what was the name, choose max, okay, choose max v, okay. It's going to return me a shape pointer, and I can take its area and I can print it out. Okay.
Okay. And this returns a shape pointer variable. Can I use specific functions for rectangle or circle, which is one?
Since you don't know what kind of shape it is returning, it could return that's a very good question, actually. Abdurrahman, this question is better than yours. What are you doing?
I'm just taking note to myself for this.
Okay. So the question is a very good question. I know it is returning a shape pointer, okay? So it has to be a shape class or that pointer is pointing to a shape class object, or the rectangular object, or the circular object, or the polygon object, whatever, okay? Can I call, for example, for the polygon, I know that there is a function named number of edges. Can I call the number of edges on it? Not directly, because why? When you say, okay, choose max arrow, or maybe that something like return radius, right? Radius, if it's a circle. But it's a shape pointer, okay? It's a shape pointer. Shape class doesn't have a function named radius, right? The compiler will fail you at this case, and it's going to say, choose max returns a shape pointer. In the shape class, I am looking at it, and the shape class is this. All you can have is the area, perimeter, and is larger. There is nothing else in it, okay? Since you are compiling this code, okay? Since you are compiling this code, you may compile, choose max is compiled before all the classes are formed. There is no way that compiler can know that somebody is going to derive a new class called circle, and it's going to be have a radius function, and etc., etc. But we will continue. We'll address your issues. I know what you mean. For some cases, it could be a circle, right? There is a way to check if the returned object is a circle object. If it's a circle object, then call its radius function. I can write an if statement in there, okay? That if statement is going to tell me if the returned object is really a circle object. If it's a circle, then I can call its radius. Okay, but for now, I cannot do that. I cannot do that. All I can do is call the shape classes one of the functions, area or the perimeter. Or so this one will print the perimeter of the largest area object on the screen.
I agree with you. This must be on a runtime possible, but in other cases, it can also be compiled detected.
I'll talk to you during the break. Okay, by the way, you have 3 tokens. You spent 2 of them. You have 1 more token. Question tokens. Any other questions? Good. So polymorphism is something simple to describe, but it's a little bit detailed to understand what's going on. Other than what's going on, why are we doing this, okay? Why are we doing this is more important than maybe what is going on, but of course, without understanding what's going on, you cannot know why we are doing this. Both questions are important, and this one is a good example. So let me introduce, okay, let me done with all the new syntax modifications to our C++ language. So one keyword is virtual. I made the function virtual. I'm saying that, okay, this function, the meaning of this function, if it is called under certain circumstances, will be determined during the runtime. Those are the virtual functions. And sometimes for the base class, I don't know how to implement these functions. And I never like these kind of functions returning minus 1.0. I mean, if somebody calls it and is not careful about what is being returned, and you may end up printing minus 1.0 on the screen for the area of the rectangle or something like that. So I don't like it, and this doesn't make any sense. That's why I'm returning something that doesn't make any sense. Some people say that, no, don't do this. Just exit 1, right? Just terminate the program. Nobody should call it that way. Or better yet, we can do this. We can do this. We are going to say that I am not going to implement these virtual functions. These virtual functions doesn't make any sense in terms of implementation for this class, so they will not be implemented. So what does that mean? Well, I don't have to write that meaningless code, exit 1 or return minus 1.0. All I'm saying to the compiler that these 2 functions doesn't make sense, their implementations for this class. Of course, these function headers make sense. What I'm saying here is that anybody deriving itself from shape has to define this area and perimeter, because you are not going to be inheriting any implementation from me. You are going to inherit only the interface of these 2 functions. not the implementation. If you don't implement them, then you don't have those functions. Okay, you don't have those functions. Why don't I make these red so that we can see 0 and 0. Okay, so what kind of a shape objects are objects? Okay, I mean, what kind of objects are shape objects? Okay, well, shape objects, when you say shape, when you say shape S1, okay, can I call S1 dot area, S1 dot perimeter? Of course not. Why? Because they are not implemented there. Right? So what kind of a class is this? We call these classes abstract classes. Really, they are called abstract classes. Okay, these are abstract classes. Okay, this class is an abstract class shape, and abstract classes cannot have objects. You cannot write shape S1. Compiler will give you an error message. You cannot instantiate abstract classes. So you are writing a class for which you cannot define any objects, you cannot instantiate it. Weird, right? Weird, but doesn't make sense in terms of making objects, but it makes a lot of sense for this kind of usage, for this kind of hierarchy. I know the shape class is an abstract class. I cannot have any objects of shape class, but that class is going to be useful as a base class for the other classes. These are called concrete classes, okay? Concrete classes. Concrete class. Soyut sınıf, somut sınıf. Okay, you may say, what is concrete about software, piece of software? Well, I mean, this is the world of computer scientists. I mean, everything is, of course, everything in computer science is abstract, but some things are more abstract than the others. Okay, so this is a concrete class. Concrete class, concrete, this is abstract class. Okay, so concrete class is something that all the classes up to now that we had written were concrete classes. An abstract class is a class that includes at least one virtual function with no implementation. By the way, these are called virtual functions, but these are called pure virtual functions. Okay, these are called pure virtual functions. Why they are pure? They are virtual. They are pure because they don't have an implementation. Okay, these are called pure virtual functions. They don't have any implementation. So as I said before, you cannot have this S1 anymore. C1 is okay, but S1 is not okay. Okay, so I don't think that I am going to tell you anything new in terms of syntax in this chapter, but well, there is one more thing, but it's not new syntax. Anyway, we are going to come to that one. So let's go back and let's try to make some definitions and some, okay. So we talked about this late binding and early binding. Up to now, up to this chapter, what we did is always early binding. Compiler knows which function to call during compilation time. I know it. I know its name. Late binding says that for virtual functions, okay, for virtual functions, whether they are pure virtual or non-pure virtual, okay, the decision on which which function call will be made during the runtime. So if the decision will be made during the runtime, then there should be some CPU running to make the decision. So that means what? Late binding is more expensive. Because if the decision is made during the runtime, who's going to make the decision? Your code. So your code is going to spend some CPU time to find the function to call. So late binding is more expensive in terms of runtime. But it is more flexible. It is more flexible. Why? I can write this kind of generic code. Okay? Good. Okay. So late binding and early binding, talk about that. And let's talk about this too. Up to now, what we did was not writing non-virtual functions. If you don't use the keyword virtual, then what you are writing is non-virtual. Up to now, we did early binding all the time. Up to now, we write concrete classes. Now I told you how to write virtual functions. Okay. With the virtual functions, when you call them, well, I need to be very careful about that. Not all virtual functions are decided during the runtime, it is the late binding. If you call them in a specific way, it is decided during the runtime. But if you do it that way, it's called late binding. And any class that includes at least one pure virtual function is called an abstract class. Okay? Pure virtual function is an abstract class. Good. So, did I miss anything? Okay. I did not talk about this one. Remember redefining. What was redefining? Redefining is
Redefinition of virtual function.
what?
Redefinition of virtual function.
Redefinition of the functions that you have inherited from the base class, right? Yeah. But if you do the same thing for the virtual function, it is called overriding. So overriding is kind of redefinition. It's just a terminology, okay? When you redefine a virtual function, it's called overriding. Override. Sometimes people use these interchangeably, and sometimes I do that too. But redefinition is something more general, okay? So if you redefine, remember we redefined the what? Print check function, right? Of the employee class for the base classes, or get net pay, etc. So we redefine them if we don't like their implementation for regular functions. But if the function is a virtual function, then that's overriding. That's override. Okay, what else? I talk about that. Okay. We like classes in object-oriented programming languages that contain only okay, pure virtual functions. Okay, there are classes that contain only pure virtual functions, no implementations at all, only pure virtual functions. Okay, we like those kind of classes. Okay, and when you design a new piece of software, okay, you are advised to write your code against these kind of classes. Okay, classes that do not make any implementations. Well, if you include shape.h, and if you write your new classes using that information on the shape.h, you are not dependent on any implementation, right? Because this class doesn't have any implementations in it. Okay, so that means what? You are very free to use any new class derived from shape class, right? And you are not dependent on any implementation inside the shape, because I didn't use any implementation information, etc. So one of the object-oriented programming principles is this: write your code against interface. Interface means an abstract class that doesn't have any implementation. That's the interface. Write code against interfaces. So include a header. In that header, there should be classes that doesn't define any functions in it. So my code, even if I like to, is not dependent on any implementation. Remember the information hiding principle, encapsulation principle? Hide the implementation details from your customers, right? Interfaces, or the pure abstract classes, okay, are perfect ways for that because they don't include any information. Even if you like to, you cannot put the implementation in it. So you are dependent only very abstract, very abstract classes. Okay, so that's one of the rules of object-oriented software design, and you are going to learn about this, I guess, in your fourth year elective course, software engineering 2, etc. Okay, so these are some design patterns. Maybe I will invite somebody at the end of the semester and he will talk about this. I mean, I'm just giving you the building blocks for the object-oriented program design. I am not teaching you how to design software using object-oriented programming principles. I'm just teaching you the building blocks, right? So the software engineering side is very different. Some people are very confused about writing a program and designing software. They are very different, okay? Of course, knowing how to write good programs is something that you should have as a skill, right? But the more important thing is that how to design software systems. And that requires engineering knowledge, okay? Designing always requires engineering knowledge. If somebody designs something, if somebody designed this building, they draw the blueprint, they made all the calculations about the strength of the materials and the usage and the etc. Implementation of this building is just putting the bricks on top of each other and doing some logistics work, okay? I mean, what is going to come first, the sand for the mortar or the bricks will come first, and I said that kind of stuff. Other than that, it is not a very difficult thing. As long as you have the money and the resources, it's not a difficult thing to make a new building. Design is important. So we are not talking much about design here. We are talking about writing programs. If you are given the design, okay, you are supposed to write the program, and that's what programming is. Okay, that's what programming is. Without knowing how to design programs, you are not a very good engineer or software engineer. Okay, good. Let's. Do you know why I wrote this? Do you know why I wrote this here? I am saying that to be able to compile the shape CPP, you don't need any of these, right? You don't need any of these. That's it. Okay, shape CPP could be compiled by itself, but to be able to compile circle.cpp, of course you need shape.h because circle CPP depends on shape.h. So all I am saying is that if I put this code in, shape CPP, I am okay. Without knowing anything about the classes derived from shape class, without knowing anything about them, I can write this one, or I can write, of course, this one, implement this one. Good, okay, let me move on. Any questions? Well, let me go to the book and we talk about this PFRAD thing. No, I am going to do I have chapter 15? Right, chapter 15. Did everybody get the source code from the book? Did everybody get the source code from the book? Did anybody get the source code from the book? So how are you following the classes then? So you didn't try it or you couldn't find it?
I tried, but I found I didn't find something, maybe a little bit.
You couldn't find the whole thing?
Yeah.
Just part of it?
I have missed part.
Well, I mean, if you buy, oh, well, I should erase these. This is 29th, right? This is 29th. Okay, I might be out of this space. Good, because I have uploaded those. Let me go to. Where is it? If I load it here, let me load the new code. Okay, chapter 15, And inside chapter 15, this one, yeah. I am going to load the whole thing. Okay. And I'm going to get rid of this PFRAD stuff. Okay, this one will go too. Okay, well. Employee age. Okay. Employee has this structure: first name, last name, social security number, they're all strings. Okay. And employee has a constructor, this one. Employee has a virtual destructor. What does that mean? Virtual destructor? Why would I make something virtual? I make something virtual because I like its meaning to be determined during the runtime, right? Late binding. But why would I make something a destructor virtual? Weird. This keyword is a new thing, okay? This one default, okay? This was introduced in C++ 11. It says that, okay, my employee destructor will be the default destructor. So you are in a way saying that, okay, whatever the default destructor, I accept it, and this is an explicit way of saying it. Explicitly using the default destructor. I can do the same thing with employee too. Employee, okay, default. You can say this too. So it means what? I accept the default constructor for employee. What is the default constructor for employee? Call the default constructors of all the data members, right? So do I have to write it? Well, for most cases, I mean, if you don't write any constructor, there will be a default constructor built for you, right? That's the rule. In this case, you are saying that, okay, I know what's going on and I accept it. But in this case, since I have defined line 11 a constructor, the default constructor will not be defined for you. That was the rule, right? The default constructor will not define for you. Here I am saying that my no parameter constructor will be the same as default constructor. I cannot, okay, will be the default constructor, okay? So I can say that too. So that don't get confused about this default keyword. Default means that, okay? Or sometimes I say this too. Okay, employee. Let's write a copy constructor. Const employee, a reference, right? A reference. Yeah, I found it. Again, this one is in the C++ 11 too. You are saying what? Well, I know if I don't write anything, you are going to give me a default copy constructor. You are going to give me that. I don't want it, okay? So this class will not have any copy constructors. So that means what? If it doesn't have any copy constructors, that means what? What?
You can't copy my class about.
And you cannot make a call by value with my objects, right? You cannot return copies of it, right? Assignment is there, but if you like, you can delete the assignment operator too. So this default and delete are two new C++ 11 additions. Anyway, let's go back to this one. What is virtual? Wake him up. Usually people sleep in down up there, not in the front row. Okay, so what is this virtual? Let's look at this example maybe. Okay, let's say I have, can I write this? Can I write this? Since I am writing it, then so that means I can, right? But would the compiler say shape pointer sp new circle 2.1? Can I write this? Is that a relationship, right? Yeah, I can write it. No problems. Can I do this? Delete sp. If I can assign a pointer to it, I can delete it too. But what kind of destructor would be called in this case? Who is destructor is going to be called? No. Shapes destructor. Why? Because compiler says that sp is a shape pointer, so it's a shape. I am going to call it shapes destructor. But in fact, I am pointing to a circle object, right? So what am I going to do? I tell the shapes destructor that you are a virtual destructor. So what does that mean? You are going to make the decision during the runtime. So follow this pointer, find the object. Object is a circle object, so call the circles destructor, not shapes destructor. So if you declare your base class destructor as virtual, then it will be called properly. That's why rule for you, okay? Very well known, accepted rule. If you are developing a hierarchy, always declare your base class destructor as virtual. And in fact, line 12, I didn't have to write it, right? Because it says that use the default destructor. I am not going to do anything in the destructor. I am writing this line 12, only make it virtual. Okay?
Otherwise, it leads to memory leakages.
Yes, because you are not properly deleting your circle object. Okay, if it is not virtual. Memory leakage is another problem. Usually memory leak, yeah. Okay, so always, if you are developing in a hierarchy like this, whatever, I mean, remember what I said? In shape, usually we don't prefer anything implemented, right? We don't prefer anything implemented. Something like that, okay? So you are not going to have any memory allocations and that kind of stuff. Why bother writing a destructor? You are writing a destructor just to show that it's going to be a virtual destructor. And this is how you do it. Okay, good. And set first name, get first name, done. Set last name, get last name, no problems. And these are the social security numbers. Nicely written, everything is fine. This is the employee class. Okay, and earnings and two string. Two virtual functions. One of them is a pure virtual, earnings. I don't know how much this guy earns. I don't know, okay? Because I don't know what kind of employee it is. It is an hourly employee or it's a salaried employee or commission employee. I don't know, okay? That's why I cannot implement it. I am not going to implement it. ToString simply returns a string corresponding to this employee. It's going to have its name, last name, social security number information in it, and it will return a string for me. I can maybe print the string out sometimes. Maybe I can send a string to somewhere. I don't know. I mean, just a string representation of this employee. Okay, good. By the way, I got this from Datel and Datel. Do I have this employee? Datel and Datel. It has lots of useful code. CPP. Yeah, here it is. They have a GitHub page. C++ how to program 10th edition. If you go there, all the chapters are there. I think this is chapter number 19. Was it 19? Yeah, 12. Yeah, it is chapter number 12. So I got it from chapter number 12. If you go to other chapters like chapter number 19, so it's lots of useful code in there. Let me see what I am getting. Yeah, so this is basically about linked list, right? Yeah. So check that out. How to program 10th edition GitHub page. Okay, let's go to this one again. Employee.h. Let's look at the employee.cpp. Nothing fancy in there. Constructor, get the name, social security number, use the member initialization stuff. Okay, set first name, get first name, set last name, get last name. Okay, social security number, that's it. Oh, okay, good. ToString is just guess the first name, guess the last name, uses the plus operator that is overloaded for the string class, right? And that's it. So I'm going to return that one. Of course, earnings is not implemented. It is pure virtual. Okay, so you know you are out of questions.
But it's a good question.
Okay.
What if we have a 2 or 3 level concrete subclass hierarchy, and how we can prevent memory leakages with virtual destructors? For example, if we don't define virtual destructor for top
Well, okay, we didn't talk about the virtual. If you define a function virtual, it has to be virtual all the way in your hierarchy, right? If you drive class B from class A, then class C from class B, if the destructor of the base class A is virtual, then all the rest has to be virtual. You cannot change it anymore.
So
They will stay virtual.
what if I allocate memory for any object of some class
Yeah.
between
Yeah.
middle hierarchy, and I
That's the beauty of polymorphism. I mean, depending on the object type, it will find the proper destructor, right? Good. Any other questions? That wasn't a good question. You fooled me. By the way, who are you? Sen kimsin ya Abdurrahman? Arkadaşla bir 10 dakika verelim. Sen yüksek lisans öğrencisin değil mi? Ha? Sen bizim lisans öğrencimizsin. Neredeydin şu ana kadar sen?
elektronik bölümündeydim. Elektronik yeni bina yapınca ben bu binayı çok seviyorum. Bu ve yatay geçiş yaptım yani bu binada.
O bina yapılalı 5 sene oldu.
2017'de ben bilgisayara geçtim ama 2 sene sakatlığımdan
Korktum, yeni mahallede adamın birisi gelmiş burada derse giriyor falan diye. Zamanımı çoğunluğu alıyor. Tamam, en azından öğrencisin değil mi? Güzel. Güzel. Okay, let's take 10 minutes of break.
C++ 11'de auto keyword'ü type inference için kullanılmaya başlanmış.
Ne için?
Type inference için.
Zaten kullanıyoruz biz de.
Tamam, onu işte bu is larger'ın argümanının başına koysak.
Compile time yine.
Gene mi runtime'a düşüyor onu yapsak?
Zaten ben shape'in pointer'ının ne olduğunu biliyorum orada. Shape pointer'ı, tipi belli onun ama gösterdiği objenin tipini bilmiyorum.
Ona shape referans diyeceğine auto referans desek. O onun tipini tespit...
Otoyu orada kullanamazsın ki. Otoyu parametre listesinde kullanamazsın.
Onu şimdi arattım Google'da. Stack Overflow'da biri sormuş fonksiyonun argümanı olarak otoyu kullanabilir miyim diyor. Burada
her zaman değil.
Auto keyword'ü diyor 11'den itibaren storage class specifier'dan çıkıp type induction da bu ya. Aynen, type induction specifier olmuş. Yani bu mantıkla eğer type specifier'sa o zaman
Yine aynısı olacak. Runtime'da belli.
onu merak ediyorum. Ben mesela dün şunu düşünmüştüm. Bunu yani şimdi bunun sadece fonksiyonun işte linkin esnasında main'deki şeyin tipine göre auto koyduğumuz zaman parametre geçilen objenin tipine göre makine kodu üretirken farklı fonksiyon signature prototipleri oluşturup aynı body ile onları farklı fonksiyonları çağırsa biraz şişleyecek ama output faili ama sonuçta
Interpreter
runtime'a
yapmaya
düşmeyecek.
çalışıyorsun. Olabilir, bir şekilde etrafına dolaşır yaparsın. Esasında bunların hepsini C'de yaparsın. Bana bir tane pointer gönder. Void pointer. Bunun ne olduğunu ben içerisinde anlarım. İstediğimde yaparım diyebilirsin. Bunların hepsi bunları compiler'a yaptırmanın yolları, trikleri. Yani polymorphizm'di, şuydu buydu. Yoksa ben her şeyi bir void pointer'la hallederim değil mi? Ne geldiğini bilmiyorum bile. Gelsin içine bakayım, ne olduğunu anlayayım, ona göre değiştireyim falan. Runtime'da verilecek kararlar bunların hepsi.
Acaba diyorum onu hani bu Godbolt'da yapsak oto yazınca runtime'a düşüyor mu yoksa kendisi?
Olabilir, öyle bir şeyler vardı. Bu
Yapıyor.
özellikle şeyle beraber, lambda expression'larla beraber, lambda expression'larla çok alakalı. Runtime'da program yazalım. Runtime'da program çalıştıralım. Tamam mı? Gönderdiğimiz parametreler, objeler falan olmasın, kod da gönderelim. Bunların hepsi o türlü hikayeler ama onlara girmeyeceğim ben. Çok fazla object oriented stuff değil onlar. Yani C++'a yapılmış, Python'dan etkilenmiş hikayeler, şundan etkilenmiş hikayeler. Tamam.
Oğlum bu Python çıktı. Nasıl Python?
Hayır, yeni bir şey.
Evet, işte Python.
Yeni versiyonları Python'da Pas'tan sonuçta.
Zaten işte
Bazılarına daha
hasta gibisi.
yok abi, peçeten var o. Ben de sana kullanılmış peçete vereyim. Oğlum peçeten var mı? Al, pis istedim. Kullanmıyorum ben.
Al bir tane hediyem var.
Tuvaletin yerini sildim.
Buradan baksana oğlum patlayacak gibi.
Oğlum çantana koysana öyle şey.
Olmaz. Oluyor.
Cebimde taşıyorsun. Kaç para kaybettin kumarda? Devam mı ediyor? Parşal.com. Ahmet'in çoğunluğun çocuğun rızkını yemem abi. Öyle be.
Ya kayıt almayacağız.
Bir anda bağırmam yok böyle. Kayıt almıyor ha. Yok bir an al. Kayıt almıyor.
Tansiyon almıyor.
Bir an al ben çalışıyorum. Sonra seni duyuyormuş ya. Duyuyorum. Seneye izin.
Kardeşim tansiyon almıyor.
Adam evde işte ses duymadı. Sonra duymadı. Neyse orayı izleyen
En
çıkmaz
çok
herhalde.
tekrar edilen an senin o aşkı.
Oğlum mola yani skipler muhtemelen da. Evet doğru. Onun için belki şansa bağlı biraz. Sonra tekrar mola et. Yorumlarda beni belirtmezsin. Böyle şu anda çok önemli. Ben yazarım ben. Ben yapsam bunu ben yazarım. Tamam. Ben yazacağım da çıkınca. Nasıl duyuyor? O Yusuf Hoca da çok güzel ders anlatıyor ha.
Bayağı.
Değil mi? Kime ne ilgisi var? Oha, hocamız çok güzel ders anlatıyor.
İzlemeyi çok
Belli olmaz. İlhan Hoca da çok büyük adamdır.
öğrenci not abi. Evet, sen çok bozulmuşsun.
Evet. Gerçekleri söyleyince niye bozulmuş bu?
Şimdi mi aklına geldi? Dönem bitti abi.
Yok ya.
Geçen ödemiyorsun.
Süt alabiliyor musun? Yine var. İftira. Ama
Ben
çikolata süt ben hiçbir zaman da farkmadım. Öyle yazmamış ya. Üzmüş olabilir ama. Biliyorum ben ya. Ha orada uyuyor, burada uyuyor, her yerde uyuyor. Oluyor mu lan? Ben de ne işiyoruz ki? Şeyden mi? Anlatmak için yani. Tweet'e gireceksin. Önce bir size tekrar
Aynen anamın gibi.
İyi o zaman. Bir şey kaçırmamış.
Sonra çok değişti. Ben 180 derece döndü.
Bacağım donlar lan.
İlk geldiğinde sonucu bulamayan direkt sıfır verdiğinde adam. Reklam yaptı da bana vereceğim artık.
Oğlum yoksa sonra 170 kalacak.
Oğlum bizim notlar da binary gidecek. Böyle 0 0 100 falan. O binary.
Hocam boş korkuyor. Hakikaten yani biraz baya boş yaptım. Ya çok korkmadım. Abi unuttum gitti ters
Kayıt
çalıştım.
almıyorsun.
Evet ben çok o kadar çok korktum ki yani umudum gitti abi. Ders çalışacağım ben. Bacaklarım dolmuşsun. Yok şey işlemler
Bizim Zafer Hoca
her şeye bir
sınav
şey yanlış
hiç
yapmışım.
sallamamış abi. Bildiğin geçen sene sınavı kulüpteyiz. Zafer Hoca.
Ha çok tatlı.
Adam iki
Ha döndün ya kanka.
Oğlum.
Ders sınavdan çok daha zor yani. Öyle kanka çok daha zor. Dersle alakası yok sana.
Oğlum ben bütün bisikleti tekrarladım. Sen denk geldi, çalıştığın yerden çıktı. Ben bilgiler override
Çalıştım oğlum 70 puan son soru hariç her şey aynı geçen sene.
Ama da benim bilgiler üstte bildiği için unuttum yani. Bir daha sıfırdan
Ben aşırı baktım. Aşırı baktım. Çok
En zevkli ona çalışıyor adam.
Eksprese isim ben 70 lira. Eksprese isim. Son soruları
Graph
yapmışım.
theory. Graph theory şehir için bu değil mi?
Ekrem Hoca da çok kolla delikanlı adam ama.
Ekrem değil Erkan anlatayım. Adam
Ekrem kim oğlum?
Ekrem diyor Erkan. Dönem başından beri bilerek yapmıyor. Ekrem Hoca Ekrem.
Geleyim mi lan? Evet sen buradan çıktın mı lan bir kere? Ha? Sen buradan çıktın bir kere. Ama her gün oradan çıkıyorum ben görmüyor musun? Yalan değil. Evet. Video çekeceğim. Bak. Hadi çık. Bu soğuk. Ne alakası? Bulut balık. Yağmur yağacak oğlum. Kafanı kullan. Burayı
Ekrem Hoca çok iyi adam. Zaman Google diye bir tane.
Oo, Berat Pete'ye yapmışlar.
Sonra sakar hastalığı.
Yavrum patırlısı düzenlemiş de bu işi nasıl yaptılar ya. Kim site yok, ama sitesi var ya. İçinden geçmişti. Normalde kontrol yapıp bulabiliyorsun, gidip düzenliyorlar. Öyle gözüküyor işte.
Aa bende var aslında şey.
Bol tutuyorlar.
Ekrem.
Aynen o tutuyor olmalı.
CD Ekrem.
Bir yanına geçiyorum. Şey yapıyorum. Tek işlemler başlıyor.
Yemeği açıyor oradan bir şey çok.
Yok yok vardı. Kontrol yapıp bakıyorum bıraktım.
Oğlum. Listeyi patlatmış ya. Yok komik sesini silmiş ya. Kim? Biri mi? İyi yapmışlar ama yok kopya yapmış. Kopya değil mi zaten? Bilmiyorum. Oğlum kopya da saçma ama öyle kopya. Böyle bir daha atar. Kopya değilse bende var orijinali. Nasıl paylaşırım? Değiştiremezler ki bana. Ben paylaşırım.
Şey mi yapmış? Kendini aratırken.
Her şey silmiş. Yok oğlum duruyor her şey. Hayır oğlum. Tekin aç. Recep geliyor. Gösterdi az önce.
Bunlar devamı olur. Biliyor musunuz?
Dur lan beyaza boyamış olmasınlar ya. Bak bir dur oğlum yukarı çıkamıyoruz. Çıkıyor mu? Adam sınırlamış. Yukarı çıkamıyoruz. Bir şey kim demiş mi lan? 1784'ten başlıyor. Zaten 10 kişi. Aa doğru lan.
Kandırıldık var.
Ne kadar doğru oğlum adam. Ama dur yine editlemiş
Ne göstermiyor şeyi ya. Yol sesini.
Soğuğu açabilir miyim? Ne editlemiş mi? Nasıl editliyor? Ha böyle yaptıysa editlemesi.
Yazıyordur orada. Dosyalar kısmına girsene.
Bu yapamazsın lan.
Bakın.
Acaba hocam? Yok.
Dosyalardan yoksa gönderilerden.
Dosyalarda.
Şey diyeceğim
Yok
ya,
yapmamışsın oğlum.
siz yoklama ya giremezlik yapmayan var mı o ofide?
Bilemezsin kim olduğunu.
Kaç gün yani, kaç günde
Hayır o.
bu kadar yoklama
İşler
yapar?
saplamadık.
Bak buraya çıkartmış. Yok var. Sadece gizli.
Yani tatil muhabbeti
Sadece gizli neyimden
Olmadı galiba.
kendini şey yapınca bulabiliyorsun. Neyimden seçmen lazım. Gizli sadece. Ne çıkıyor?
Nereden
Aynen.
seçiyorsun?
Neyimin şuraya basıyorsun.
Ha
Şuradan arama filtrelerinden seçiyorsun.
Doğru aynen.
Ama niye göstermiyor ben de anlamadım. Yani
Filtreyi kaydetmemesi lazım herkese. Onu editten saymıyor demek. Veri değiştirmiyor.
Şey.
Lokal olması lazım bence de.
Bak şunu seçi uygulayamıyorum mesela.
Uygulamıyor mu?
Şu an sende ne gözüküyor açınca? Şey gözüküyor mu?
Ben adını girdim gene boş çıktı. Ne yapacağız?
Dur ben yazacağım. Sen silmişler. İşte biri şey yapmış. Onları 1-2 yapmayan. Senden başkası alamaz.
Kapatsan da bulur o herkes.
Ne kadar zam.
Sen öyle düşünme. Ne kadar zam mı geliyor?
Geçen sen 500-600 geliyorsun.
Geldi kaç kere? Daha ne olacak işte şu an?
Ama zam yapıyorsun. 500-600. Zamlı zaten o. 2 kere ne geldi? Yazacağım kapatsam.
Kendini gösterir.
Sabit çekiyorum. Ondan sonra bir daha almıyor. İniyor.
Okay.
Ben tek hesap sağa götürüyor. Ondan sonra indiriyorsun. Ama şey mesela daha her adımda var.
This is employee.h. There is nothing interesting. Well, this is employee.cpp. There is not much going on. Constructors, setters, and getters. And of course, as expected, we are not implementing. What the pure virtual function earnings. Okay, so let's look at what's going on. We have salaried employee, we have commission employee, and we have base plus commission employee. Let's look at this salaried employee. Salaried employee is, well, you need to pay this type of employee salary weekly. I have my constructor and I have my virtual destructor. Okay, by default again, it's default. And set for the salary, get for the salary. And see, another C++ new addition, override. You are saying that I know that earnings is a virtual function and I am overriding it. Okay? Overriding is only possible with the virtual functions. Okay? You cannot override a non-virtual function. If earnings or toString is not a virtual, then this override here will give you a compiler error. So it's a very simple modification actually. It is only for to get help from the compiler. I mean, by writing override here, compiler is not compiling a different code. It's just a mark that you know what you are doing. You are overriding a base class virtual function. Okay? That you know the definition of override. Override means that I am redefining a base class virtual function. In this case, line 19, I have to override earnings because earnings doesn't have any implementation. If it doesn't have any implementation, it's pure virtual. If I don't override it, salaried employee class would become an abstract class too. Remember, employee is an abstract class, okay? Employee is an abstract class, okay? And the reason why it is abstract because earning is not implemented. If you don't implement earnings in salaried employee, then salaried employee would become another abstract class, okay? So I have to implement it. ToString is going to be overridden again. Why? Because it is good. My base class ToString is good, but I need to put the salary information on top of it. Let's look at the salaried employee CPP. Constructor, see, nice. I am calling the base classes constructor. And then what? I don't have no parameter constructor. No parameter constructor is not there. Yes, that's good. Remember, okay, this book has a better software engineering approach than our book. In the other example, remember employee constructor. Where is it? This employee constructor needs to have this string, string, and string. It doesn't have any no parameter constructors. It doesn't let you make an uninitialized employee. Or remember what the other book, the Savage book, it says that this is an employee with no name, etc. No employee set, something that meaningless, right? This doesn't let anything like that happen, okay? This doesn't let anything like that happen. It says that if you are going to make an employee, you need to provide name, last name, and the social security number. There is no parameter constructor this one, and there is no parameter constructor for this one. So I am going to implement it. This one I am calling the base classes constructor for the first name, last name, and social security numbers, and I am setting the salary in my constructor body. Okay, nice checks. Okay, validity checks. Salary cannot be less than 0. And get weekly salary is just returning it. Yes.
What's throw?
What?
In set weekly salary, there is a. What is throw?
What is?
Invalid argument.
Yeah. This is chapter number 16, 17, or something. Well, for now, think this as like exit 1. Okay. Okay. So line 19. Throw is a C++ statement. It is just for handling the exception handling. It just, you are telling your caller that there is something exceptional happened. Well, I mean, you may think this as like I am terminating the program. It is not termination of program, but for now you may replace it with exit 1 in your mind. Okay, good. Thank you for pointing that out. Get weekly salary and earnings is just this one. Okay, remember we didn't have a definition for the earnings. Now I have a definition. Just return get weekly salary. That's it. And ToString is what? What is this? Did you see this? It makes an O string stream output. Okay, and it says that I am going to print everything to this one output and ToString to output and output. It looks like there is a class named O string stream. O string stream. Let's look at that one. CPP reference. I guess you understand what it does, right? It is not a stream that is connected to standard output to a file, but it is connected to a buffer, and you can always take the string out of that buffer. Okay, O stream, okay. This is inheritance, IO base, IO basic iOS, basic O stream, basic all string stream. Okay, this one. And it looks like there is a function named str. This str will return whatever is collected, buffered inside my string stream object. And yeah, there is member functions, good, bad, fail, etc. I can do the formatting, miscellaneous. Let's not go into the details of it. Are there any? No, there are no examples in there, but you can understand what's going on in there. Did I miss the employee CPPs? Yeah, no, this is good, right? It's just get first name, get last name, and it is doing this. Why aren't we doing the same thing here? Salaried employee in there, employee to string in there. I could have done the same thing. I could have used the string catenation operation plus operator to achieve the same thing, but it is not doing it. I guess it is because that plus thing is a little bit inefficient. This one is more efficient. Or I know what's going on. They converted this code from Java. In Java, there is a class like this, and it's called string builder class. I think they are just imitating the string builder class. Okay, so this is salaried employee. Let's look at the commission employee. Commission employee is this. So I make my money as a commission employee by the amount that I am selling, okay? How much did I sell? Gross sales. And what is my commission? This much. And my earnings will be determined by gross sales times the commission rate. That will be it. So of course I am going to override both earnings and the toString. Okay, let's look at that. Okay, so commission is this, yeah. Earnings is get commission rate times get gross sales. Okay, that's it. And that's the whole thing. It's a nice written code. It uses the public interface all the time, get commission rate, get gross sales. Even though I can access those data members directly, I am not accessing them. I am using the public code. All the functions, they have their comments nicely written and everything. Okay. I don't know, we used to use this book. It was too detailed for some of the students. Now I am thinking that maybe I should switch back to this detailed thing again, because it is using C++ 14. And I mean, C++ 11 is good, but 14 is accepted everywhere. And remember what we did with the Google, where is it? Okay. Microsoft documentation. Didn't I take a note of Google's guide for C++ code? They said that they are. It is okay to use C++ 14 features in Google's code, right? Not C++ 21 or 17, but C++ 14, right? Google's code. So that means what? It is time to switch to C++ 14. It's not okay to directly use the latest version of C++. As I said, maybe the compilers are not up to date. Maybe some of the features will go away. And even for C++ 11, some of the features are gone. We don't use them. They are gone. But C++ 14 is mature enough for us to teach it. So maybe I am going to teach out of this book again, detail, because as I said, I am not making those criticisms that I am doing for the Savage book. It's getting old. Okay, good. So this is commission employee. Let's draw our hierarchy for this one. For this one, it says there is an employee class at the top. Employee class. This is an abstract class. There is a commission employee, right? And there is a salaried employee, and we are going to drive another class from this commission employee. It will be base plus commission. Commission employee makes money by the sales that he or she makes, right? Base plus commission employee is the same. On top of it, they get a weekly salary too. Okay? So I pay them money every week, plus they make some money out of the sales that they are doing. That's called base plus commission employee. So it's a hierarchy with more than one level. And let's look at that one. Let's look at that one. Base plus commission employee, public commission employee. See, this commission employee is public employee. Salaried employee is again public employee, but base plus commission employee is commission employee. It says, I am a commission employee, okay? On top of commission employee, which is an employee, I am going to add this base salary, okay? This is set base salary and get base salary, and that will be basically it. Well, I think I would have done it differently. I think I would have done what I would have done is, I am an employee. Well, I am a commission employee, and also I am a salaried employee. Remember, salaried employee is somebody who gets paid by week, every week, right? There is a salary. Commission employees, there is a commission rate. Also, there is a gross sales and etc. So if I did that, I didn't have to add this base salary, get base salary, set base salary kind of stuff. So I am using multiple inheritance here. So my picture, the hierarchy picture by hierarchy shape would be this way, but they didn't do it that way. So exercise for you, do it this way, okay? Change this hierarchy so that base plus commission employee is just multiple inheritance using multiple inheritance, right? It is doing that, and get rid of this set base salary, get base salary stuff, and this will be a much simpler class than this one. Okay, but I am not going to do that. So let's look at the implementation of base plus commission employee. It is here. So I am just calling the base classes, not the employees constructor, but the base classes constructor, commission employee, and set base salary time. Okay. What else? Yeah. So this one is calling the commission employees to string. On top of it, puts the get base salary. Good. So this is the whole hierarchy. We developed 1, 2, 3 classes, concrete classes, and employees an abstract class whose objects we cannot make. Okay, let's write a driver code. Let's write some driver code main function. See, I am making this employee pointer vector. Okay, employee pointer vector. Salaried employee is an employee, of course. Commission employee is an employee, of course, and base plus commission employee. Okay, so I made 3 objects and put them in this employee pointer vector. Okay, and in a for loop, I am iterating over these pointers. Okay, one by one. Okay. Well, I wonder why you are doing. I mean, you sit in front row and you play with your cell phones. Anyway, I gave up understanding you guys. I don't understand you. I guess you don't understand me either, right? That's called generation gap. I am going to, did I tell you about that Hittite tablet? Hittites tablet. What is going? What is going? I think it was like what is going on with the youth. I think there was a Hittite tablet. They found a Hittite tablet that says that what is going on with the youth, what's going to happen with the new generation. They were concerned about what's going on with the new generation. So maybe I shouldn't be concerned about new generation because I couldn't find it. Maybe I should find that tablet and make a replica of it. What is on, how am I going to find it? On youth? It's one of them. Most of the Hittite tablets they discovered are homeworks. Did you know that?
You mentioned it before.
Well, I keep mentioning it. So that means it is time for you to pass this course. Okay, because I keep mentioning it. So yeah, so it is, most of them are like that, but I wonder if this is Çivi yazısı, these are. Okay, they are using the same alphabet, the whole ancient world, they are using the same alphabet. It's interesting. Cuneiform, right? This one. Anyways, I don't know what's going on with you guys, but okay, you are back.
Should we write programs with Çivi yazısı?
Well, they know how to. You wanna work on it? You really? Yeah. Because, I mean, all Hittites, the Egyptians, Lydians, and all kinds of ancient civilizations, they use the same alphabet. But of course, their language is different, right? So it is very easy to put all those texts together and find what kind of terms are common, what kind of terms are affected from each other using deep learning techniques. If you like to work on it, just come to me.
No, I'm just making a joke.
That was a joke.
Instead of using text ID, should we use?
That's what I'm talking about, generation gap. Yeah, I'm talking about serious research here, and here's okay. Anyways, so there is a loop that iterates on the employees. So this toString is definitely a polymorphic call, right? This is definitely a polymorphic call. Why? Because this is an employee, is an employee pointer, right? Compiler doesn't know at line 28 what kind of object it's going to get, because at every iteration of this loop, employee pointer is pointing to a different type of object, right? So I cannot know what kind of function I am going to call during the compile time or during the linking time, Abdurrahman. Okay? There is no way I can figure that out. The only way that I can figure that out is during the runtime, I am going to follow this pointer and find that object, okay? And I will inspect that object and I see, okay, it's a salaried employee, so I am going to call the salaried employees toString. Okay? Good. Okay, so let's look at this one. Attempt to downcast pointer. What does that mean? Let's read this line 31 and 32. Maybe I shouldn't talk about this at this point, but I'm going to talk about it anyway. Okay, so let's look at this 31 and 32. 31 and 32 says that I am going to typecast this employee pointer to a base plus commission employee. This is your question. What was your name? Tugay? Yes. Tugay, this is your question. Answer to your question. I am trying to typecast. It's called dynamic casting. Remember we did the static casting? Static casting is same as the C cast. Dynamic cast, okay, it tries to cast in a hierarchy from one point to another one. I am trying to downcast an employee pointer to a base plus commission employee pointer. So an employee pointer to a base plus employee commission employee pointer. This is always valid. There is always an is a relationship in this case, right? Is a relationship. Every base plus commission employee pointer is an employee pointer. That's why I can do this, right? This is an employee pointer, but I put a base plus a commission employee pointer in it. No problems. I can do it. How about the other way? The other way is, maybe I should do this. Green. Green is a relationship. It is always valid. It is always on. But how about the other one? Is an employee pointer always a base plus commission employee pointer? No, not always, but sometimes, right? Some of the employee pointers are base plus commission employee pointers. So how am I going to know that? This is what I do. Okay? I typecast this employee pointer using this operator dynamic cast to a base plus commission employee pointer. If this typecasting is successful, then it's going to give me a non-null pointer back, and I'm going to check it. If it is not null pointer, then it means that this conversion is successful. If it is a null pointer, then this conversion is not successful. If it is successful, okay, this derived pointer is not a null pointer, then I can call this, right? Derived pointer get base salary. I got it. Okay, derived pointer get base salary. I got it. And then what am I doing here? I am printing the old salary. Yes, it looks like I am making a raise. I am giving a raise to this guy, right? Set base salary to 110% to old base salary. I am giving him a 10% increase. And that's it. It looks like this loop is printing everything about my employees. Let's say I'm a boss. I hire many people, and some of them are base plus commission employees, and I'm going to give them 10% increase, only them, not the commission employees, not the salaried employees, but only the base plus commission employees. I am going to give them some raise, and I am going to print their earnings on the screen one by one. By the way, this is a polymorphic call too, so it's going to call the right one. Okay, Tugay, you got it? No? Is this your question, right? No? What? You don't like it? Read it again, okay? I showed you where I got this code from the GitHub page. Find that GitHub page and look at this one. So this is specific code. This part of the code, make this a little bit smaller. Okay, everything is in this main. Everything in this main, okay, especially in this loop. This is generic code. This is generic code. This part is only specific for base plus commission employee. Okay. We don't like writing specific code, but if you like to write specific code for base plus commission employee, then this is how we do it. Okay? I know what you think. You are thinking that, okay, these are all kind of forced examples. I mean, what is the real world value out of all these polymorphism kind of stuff? I'm going to show you one example, as I said, an example that will make things a little bit clearer for you. Yeah, this is not exactly correct, but I mean, kind of approximate information. In Windows, okay, there is a class called WinApp. Okay, Windows application WinApp. This WinApp class is an abstract class. Okay, if you like to write a Windows application, you need to drive your new application from this class. Since this class is an abstract class, it has pure virtual functions. For example, It has a pure virtual function close. It has a pure virtual function resize, minimize, and etc. Okay, that's the class. Okay, so if I am writing a new Windows application, for example, a calculator, I need to derive myself from WinApp, and I need to override, okay, this close function, resize function, minimize function, save as function, and etc. If you don't do that, okay, your program is not compilable, right? Why? Because you become another abstract class. If you do all of them, if you override all of them, then Windows will take you as a Windows application. This way, Windows makes sure that all the programs that runs on this Windows operating system will have a close button, will have a resize button, will have a minimize, and etc. Right? That's how we write Windows programs. And let's look at this close all function that Windows had written like 10 years ago. Okay, 10 years ago, the Windows operating system wrote this close all function. That close all function takes the vector of all the Windows applications running. I don't know how many programs are there. Okay, vector of all the Windows applications running like this, and it runs this loop. An application, okay, pointer, apps, it just calls their close function one by one. Each application knows how to close themselves, and I am calling them one by one. Not all the applications close the same way. Some of them close directly, no problem. Some of them, before closing, they need to save some files. Some of them, before closing, they need to close some network connections. Some of them need to say, before closing, do such and such, etc. Everybody define their own close behavior, but this code will never change. Okay, when I shut down the computer, when I say close this computer, okay, shut down this computer, okay, before shutting down the whole operating system, I need to call this function close all, and close all did not change for the last 10, 15 years, 20 years. It is exactly the same. Doesn't matter how many new applications I am writing for the Windows operating system, it is always working the same way. Or minimize. You know, when you hit this Windows M button, everything is minimized, right? So there is a function somewhere that's called minimize all. It's exactly the same, but only this time you say app arrow minimize, right? So these functions never change. For the last 20 years, they work exactly the same. Doesn't matter how many new applications I am writing. As long as I follow these rules, my programs will work in harmony with the Windows operating system. If I don't write it, if I don't implement any one of them, then I cannot instantiate my new Windows application because it becomes an abstract class. Yes?
Since it's an abstract class, why does that constructor exist?
This one? Abstract class doesn't mean that it doesn't have a data member in it. Remember, employee is an abstract class. Employee is an abstract class, right? Because there is a pure virtual function. Still, I have this first name, last name, and social security number, right? So my constructor needs to initialize those three. Still, I am an abstract class. I cannot make objects of it. But it is nice that I put together anything that is about the first name, last name, and social security number in this class, in terms of initialization, in terms of getters and setters. Yeah? Okay?
Alright, but it can't have any instances.
Yeah. Well, I mean, who is going to call this constructor? Of course, I am not going to make an object of this employee, but remember, this commission employee, it calls the constructor of the employee in its constructor, right? So this one calls it, and this one calls it, right? Way deep down, base plus commission employee, it doesn't call the employee directly, but when it calls the commission employee's constructor, that one calls the employee's constructor. So it is called in many places. If I didn't do that, I have to repeat that code, and that would be bad. Okay, a good question. Any other questions? Good. Okay. So we talk about this one, the code. We talk when I teach you Java programming language. Okay, all I'm going to say that for the inheritance. I guess I've been talking about inheritance for the last 6 hours, 7 hours, whatever. Okay, so at the end I will be talking about this inheritance maybe for more than 10 hours. When I teach you about inheritance in Java, I am going to say that in Java the meaning of inheritance is the polymorphism is exactly the same. The only thing the thing is the syntax. You don't write your Java inheritance like this. You write it in a different way, so it's going to be a 10-minute discussion. So that's why it's going to be very fast. Or composition, or public-private protected stuff, or anything that we learn about object-oriented programming. They all will be like 10-minute discussions. I will only tell you how to do those in Java, right? So the idea, you already know that. So where am I going to spend my time in Java? I am going to teach you how to write graphical user interfaces, graphical user interface programs in Java. And Java's class hierarchy for the graphical user interfaces uses this polymorphism idea a lot. So we will be talking practical uses of polymorphism with the Java programming language. Okay, so let's go back to the slides. We talked about it. Okay, and yeah, let me go to, we talked about this too. Yeah, by the way, yeah, to be able to use polymorphism or virtual calls, function calls, you need such a thing, okay? Let's say, okay, let's say this is my class hierarchy. Class A, class B, and class C. Let me make another one D, like that. Okay, so I can say things like A, B. Let's say there is a virtual function in there, virtual V1. Okay, A and B. If I say A.V1 or B.V1, okay, these two are definitely non-virtual function calls. If you call those functions directly on object names, they will be non-virtual. There is no polymorphism going on. These are all early binding. Early binding. Okay, these are all decided during the compile time. You might say, well, V1 is a virtual function. Yeah, I know, but if you call it this way, it's a virtual function. Okay, but if I do this, APTR gets the address of object B. Then if you do this, AP V1, okay, this is now a late binding example, okay, late binding. So in order for polymorphism to work, you need to have a pointer, and you need to keep a pointer to the base class, or another one is this, a reference AR B and AR dot V1. Again, this is late binding too. Why don't I use different colors?
Why don't we use also
Late binding, late binding. Okay, so this one is late binding and this one is late binding too. So what I'm saying is that you need a pointer to a base class or a reference to a base class to be able to use polymorphism or late binding. If you call these functions directly on the objects themselves, okay, that's non-virtual. That's early binding. Just simple syntax rules. They make their decisions this way. We can talk about why they did that, etc., etc. No, I don't have time for that. Yes.
Isn't there a mistake?
Where?
AP assignment before the AP.
You mean it's a pointer, right? Yes, sure. A pointer, and it should be okay. Good, thank you. Okay, so I gave you some information about how to make polymorphic calls, and this is how you make the polymorphic calls. You need a pointer to a base class. Okay, without a pointer, without a reference, there is no polymorphic calls in C++. And polymorphic calls are expensive, as I said before, because during the runtime you need to figure out which function to call, and how to implement those will be a little bit involved. I'm going to talk about that too. Good. Any questions? Okay. If there are no questions, I think I will stop at this point. Tomorrow we will continue.